viruses himself, the way how they keep and protect their DNA is by creating viral capsids. So that is a really very solid structure that they just can survive. As part of my project, one of the interesting things is that we got some museum samples from bombs, from the Natural History Museum here in Denmark, and from the Natural History Museum of Oslo, of sea turtle. They were collected 170 years ago. So they was really, really old, and one of those really famous Danish expeditions, Galatea probably, or some other expedition, and they retrieved two samples and brought it here to Denmark, and the shells of the animals were simply put for exhibition there, and they were there for 150 years whatsoever. Or a small hatchling that we just put in a flask with formalin. That in those days it was believed it was the best way to preserve samples. Now we know that it's not. And I got my hands on those samples and start playing with it, trying to follow in the procedures for doing ancient DNA extraction. And I managed to get a full mitochondrial genomes from those samples. The interesting part is that I also tried to capture a part of the herpes virus genome, and I think that we thought it was not possible for the same reasons I have been telling you, that virus survive in a viral. What is known about the viral biology is that they survive in a capsid, but we managed to find viral sequences. They have survived for 170 years. So the main question, if you look at the evolution of viruses, well, flu virus for 20 years ago is considered already an ancient sample because of the mutation ratio. But a herpes virus for 170 years old is something very, very, very old. So we are also in the process of analyzing the data right now to see whether it's something that we can really, really trust. It's something that we can really, can we rely on this data, that the sequences are real, or is something that it might be just some random sequences that just give a hit to that. But it's something, it's very interesting. So how all viruses can be, if they can survive a long time, until now, I believe in myself, no. But now I'm finding myself that yes, they can do it. So I need to still go through the process to really explain and understand how did that happen, or where did they survive. Probably once again, in the case of herpes virus, because their ability to survive in latency, but if they survive in latency, they must be somehow incorporated into the total genome, and that's the part that we have been able to prove. So we're like having some linkage that probably need more analysis and more study. If you take a piece of meat and you put it in the freezer, the DNA, it will survive there for as long as you want. The lower the temperature and the more completely isolated from light, that sample would be really, really potentially 100 years, definitely, for doing any ancient DNA study. So that's a really, really good, and absolutely is believable that they were able to cut samples from the Spanish flu from, the Spanish flu was something in the beginning, northern part of the world, that really, really good for ancient DNA studies. Because if you have the opportunity to preserve DNA, then if you have the opportunity to preserve DNA from the human, from the host, of course you will have a high potential to find any other pathogen or parasite infecting the host.